Assalamu alaikum. In today's video, we're going to talk about IP addresses and the classes that uh, classify these IP addresses, and some basic commands that we can use to get the IP address, and some other information, including our DNS servers and how our IPs are converted into a domain name, and then reverse from the domain name to our IP address that are done using the DNS service. So we will briefly talk about all these things in this video. So let's start. If you can see on the screen, an IP address, and specifically an IPv4 address, is made up of 32 bits, and it contains 4 octets of 8 bits. Okay, and because there are 8 bits in every octet, that's why it's called an octet. Octa meaning 8. So each octet that can be written x dot y dot z dot a, or whatever variable that you put in it. So in this format it can be written, and the minimum value that can be in any octet is 0 when we turn all the bits uh, in the octet to 0, and the maximum value can be 255. Okay, so this sample that you see here, that is read as 123.89.46.72. So it's the period in between these octets is written as a dot, not as a point. Okay, so in this way an IP address, or specifically an IPv4 address, is written. And the classes that I talked about, these are the classes. Basically 3 classes, class A, class B, and class C, uh, are used in daily life networks, and class D and class E, that are beyond these ranges, they are not used in daily networks. And the class D is specifically for multicast purposes, and the class E is reserved for research purposes. So those IPs are not assigned to anyone. And in these IPs, there are 2 type of IPs. One is called a private IP, and the other a public IP. And as you can see from the small descriptions here, private IPs are used in LAN networks, and public IPs are used on public networks, or you can say internet. Okay, each IP that can communicate with internet is assigned by our service provider or IANA. Basically, what happens is that we mostly get our IPs from a service provider, that those service providers get those IPs from IANA. So these are uniquely global, the public IPs, but the private IPs are only unique in our LAN environment. Okay, and as this image states, that private IPs are free of charge, but there is a cost associated with using public IPs. So what are these ranges? If you see on the right hand side, class A, and the valid combination that we can get are from 1.0.0.0 to 9.255.255.255. That means 1 to 9 is the complete network, and then from 11 to so on 126. Okay, so what signifies a class is the first octet. So if the range of the first octet is from 1 to 9, or 11 to 126, or if we include our private IPs, you can say in short that if we see an IP from 1 to 126, those IPs will belong to class A. Okay, so class A IPs start from 1 and they go up towards 126, and this significance should be checked in the first octet. Okay, whenever there is 1 to 126, an IP comes in between these ranges, Okay, and if it starts in between these ranges, they will be in class A. And for class B, the range starts from 128 to 191, and for class C, 192 to 223. Okay, this is just a brief description. If you want a complete article on this, you can Google it, IP addresses and their classes, and you can get complete detailed information about these classes and how this works. I'm just stating a brief introduction because we are going to practice some commands. Okay, and these IP addresses and these classes will be also used in our next lectures, so we need to have a little bit of information about them. So private IPs and public IPs. Private IPs can only be used on a LAN environment, and public IPs are only used on public or internet or WAN environment. Okay, private IPs are free of cost, and public IPs are associated with a cost. Okay, so with respect to class A and class B and class C, uh, each IP or each IP class has a subnet mask associated with it. So the first class, that is class A, has the subnet mask of 255.0.0.0. Now a subnet mask is something that will be used to tell how many bits are used for a network part and how many bits are used for host part. Okay, so what that means is, in any class, how many PCs or how many network devices, network capable devices we can connect, the subnet mask will tell. uh, okay, so the segregation for class A is that it contains 8 bits. The first 8 bits are for network and the last 24 are for host. And this, in class B, first 16 are for network and the last 16 are for host. And similarly in class C, first 24 are for network and the last 8 are for hosts. So with regard to number of maximum number of hosts, class A has the bigger number, class B is slightly smaller than class A, obviously, because it contains 16, and class C is only contains 8 bits per host. So if we want to get the total number of hosts, we can apply the formula 2 raised to power n, where n being the number of bits. Okay, so since class A has 24 bits for host, so if we apply the formula 2 raised to power 24, then we can get the total number of hosts that can be used in using a class A IP. And for class B, 2 raised to power n equals 2 raised to power 16, because class B contains 16 bits per host. And similarly, class C contains 8 hosts, so the formula will become 2 raised to power n equals to 2 raised to power 8. Okay, so these are the total number of hosts. And then in our other lectures, we will also be discussing about the valid number of hosts. So if we talk about valid number of hosts, 2 raised to power n minus 2 will be the valid number of hosts, because the first host and the last host are also reserved, so they are not used. Okay, so this is a brief introduction on how we can assign IP addresses. Assigning an IP address is very simple, and we will be doing that in our next lab also in detail. So for now on, we will just be focusing on the basic information, that how many classes are there, how we can identify which IP belongs to which class, that is using the first octet, and if the range belongs between 1 to 126, then it's class A. If it's 128 to 191, then it's class B, and if it's 192 to 223, then it's class C. Okay, so since we have a basic understanding of IP addresses, now let's move on towards some of the basic commands that we can use to get our IP address, or how we can check which IP address has been assigned to us. So For example, if we jump towards a command prompt, and if we type command ipconfig, so if we do that, we will be presented with a lot of information. I have actually multiple Ethernet adapters. Some of them uh, are not physical, they are logical, and etc. So for most of you, you will only get a single network adapter, or mostly either one or two. So what you have to uh, look for is Ethernet adapter. Okay, just like this one. So I have renamed my adapter to internet, and you will most probably don't see internet here. You will see uh, Ethernet adapter local connection or something like that. Okay, so what you have to see is the IPv4 address. So on any device that on which you have a admin access, you can uh, run this command ipconfig, and you can get your current IP configuration. Okay, so this is your IP configuration, and you can see this is the subnet mask. So this is actually if you see, this is a class A address. Actually, this is a subnetted IP address, which we will cover later, but for now this command is used for checking your IP address. So in this way, if you apply this command, you can get your IP address, or whichever PC you are on, you can get that PCs or that device IP address. Okay, so if you want to see some further information, for example, some more detailed information, you can apply ipconfig slash all, and now if you see, you will get a detailed information, and this detailed information also contain your MAC information and etc and etc. Okay, so in this way you can get some detailed information. You can also uh, get your gateway address, your DNS servers, and etc. Okay, so ipconfig slash all can be used for a detailed overview of your current network configuration. Another command that is widely used is the ping command. Ping command is used to check connectivity of any device. How it works is it sends a sample packet to the destination. The destination can be either an IP address, or it can be a name, specifically called a domain name, like google.com or facebook.com or etc. Okay, and the thing that we talked about earlier, the DNS service. So that's actually working behind this, that will be converting our IP into uh, a domain name, or our domain name into an IP address, because each computer, whether it's in a LAN environment or a WAN environment that we simply call internet, they all communicate over IP addresses. Okay, so each of them have a unique IP address, and the connectivity uh, is handled using those IP addresses. But IP addresses are not that easy, as you can see, to remember. So a domain name service was introduced to map human recognizable names, or human understandable names, to those IP addresses, so we can remember more websites, as you already do. Okay, so it's easy to remember some website names rather than different IP names. So for example, if we want to check Google, that if it's working or not, so if I write google.com, if you see, it's pinging google.com, but it's pinging exactly the IP address of Google. Okay, and if you see from down here, the reply from, the reply is also from the IP address, the same IP address that it got from the ping. Okay, so from here you can also see that the connectivity or the reply message that was sent to us was from an IP address, not from a DNS, sorry, not from a domain name. So this is actually the conversion that's being done by a DNS. For example, now if we ping 142.250.181.174, and it will still ping. So these are the two combination. Either you ping using a domain name, or either you ping directly using the IP address of a certain machine. So every website that's running, it's running on a machine, so it has to have a IP address, otherwise we cannot access that certain website or any other machine, whether it's in our local environment or it's on the internet. Okay, so everything needs to have an IP address. And another command that's used is trace RT. So this command is used to trace uh, the complete path from a certain device, for example this my computer, to google.com. So trace route, how it works is that it will map out how many routers it passed to get to this certain website. Okay, so this is how this works, and if you can see, it's mapping out the path from my current computer, and it will go upwards towards the end, that is our destination, google.com. And if we just wait a bit, it will complete the trace, and you can see that it will end at this IP 142.250.181.174, because this is the destination IP of google.com, or the server of google.com that's closer to me. Okay, and you just have to wait a bit more. For some reason it stopped. Let's start again. Okay, it's carrying on. There might be some delay while reaching the server. Okay, there you go. We started to trace this, and these are the routers that it passed to get to this IP. Okay, so in this way you can trace uh, from the source to the destination, that how many routers are involved in there to get to our destination, that is this one. Okay, okay, so we talked about DNS server. So this is a sample diagram that's explaining how DNS works. So if we see that the end user is requesting example.com, for example, and this would be any .com website, so it will go towards the DNS roots name server, and it will forward us towards the top level domain .com server, which contains all the registries about the .com servers. So from that TLD server, we will be routed towards the route 53 server is actually that actually registered our website. Okay, so it will know the exact address, exact IP address of that website that we are requesting. So the TLD, the .com TLD server, will refer us to the registrar server, or the registrar name server, and from there we can get the exact IP, like this 192 equal .0.2.244. Okay, for example, this is the IP address. So it will provide us that IP address, and it will be provided to the user, and the end user will then directly communicate with the server using that IP address, and uh, a web page or whatever service that web server was providing, it will then be provided to the end user. So this is how DNS works basically. So in a nutshell, whenever we type a command, it will use a DNS server to convert our IP address into name and name into IP address. So for example, if we get this IP address, and for example, I will switch back to Chrome, and if I write that IP address here, the Google's IP address that we got from the ping command. Okay, so watch closely. That was 142.250.181.174. 181.174. So if you write that, you see it's automatically converted to google.com. So what happened here was this DNS process. So even if we wrote the IP address in the browser, it was converted into google.com. Why? Because on the back of our request, the IP request, this was working, and it converted that IP address, that's called a reverse lookup, to our domain name. Okay, so that's how DNS works in the back of our systems. Whichever OS we are running, DNS is there, and if the DNS is not there, we will need to have exact IP addresses to communicate with any website on internet. Okay, so that would be all for today's video, and we will inshallah join next time. Take care.